So more factoring quadratic trinomials where a is not equal to 1. So problem number 1 and problem number 2 are going to be exactly the same. So I just want to show you that we're going to be doing the same problem in two different ways. And I'm going to start with the long way. So suppose that you leave it as it is, and you say that a is equal to 8, b is equal to 26, and c is equal to 20. Sorry about that positive right there. I accidentally wrote negative right there, so I had to make it positive right there. So suppose a is equal to 8, b is equal to 26, and c is equal to 20. So in this case, we're looking for two numbers that multiply to AC. In this case, a is 8 and c is 20. 8 times 20 is positive 160. And we're looking for two numbers that multiply to positive 160 and add to b, in this case, positive 26. Okay, so it multiplies to a positive and adds to a positive, so the combination of the two numbers need to be positive, positive. So let's list out the suspects. Let's start with 1 and 160. 1 times 160 is 160. 1 plus 160 is 161. Yeah, well, we've got a long way to go before we get to 26. Okay, but let's try 2 and 80. 2 times 80 is 160. 2 plus 80 is 82. Okay, we've made some improvement. 160 divided by 3 is a decimal. So let's try 4. 4 goes into 160 40 times. Then 4 times 40 is 160. 4 plus 40 is 44. Okay. Let's try 5 goes into 160. Alexa, 160 divided by 5.
160 divided by 5 is 32.
So 5 times 32. 5 times 32 is 160. 5 plus 32 is 37. Okay. Okay, let's try 6. 6 goes into 160. It doesn't, actually. It doesn't because it's not divisible by 3. Okay. 160 goes into 7. It doesn't. 160 divided by 8, though. 8 times 20 is 160. 8 plus 20 is 28. Okay. Well, that didn't work. Let me try 9. 9 doesn't work. 160 divided by 10. Oh, that does work. So let's try 10 and 16. 10 times 16 is 160. 10 plus 16 is 26. Whew, got it. So that was nerve-wracking, but we got it. And now we use this information to split the middle term, because now we've got 8x squared plus 10x plus 16x plus 20. Okay, and now I'm going to put everything in their respective spot. So I've got the big fella, 8x squared, in the corner. I've got positive 20 in the other corner, so top left and bottom right. And now the split bx's, they can go in either spot. So I'm going to put positive 10x here and positive 16x here. Okay, I'm going to cover up this column right here. How do I factor the GCF of 8x squared and positive 10x? I'm going to take out a 2x, because 2x is the biggest factor I can take out. 2x times what is 8x squared? 4x. 4x times what is 16x? Plus 4. And finally, 2x times what is positive 10x? Positive 5. Okay, so what you'd be thinking is you could factor this into 2x plus 4 times 4x plus 5. And I would give you 4 points out of 5 because remember the directions say factor completely. Technically, this is not factored completely. This is fine. The 4x minus 5 is fine. But what can I do with 2x plus 4? I can factor out a 2, leaving me with 2 times x is 2x. 2 times 2 is 4. So technically, this whole thing factored out would be 2 times x plus 2 times 4x plus 5. That is how you would factor completely. So, first off, I just want to acknowledge that this was annoying. This took forever. In fact, I had to use the Amazon Echo because I forgot. I thought I could do all the calculations in my head, so I was like, "Oh, good thing I can yell." But the point is, I didn't even know what that combination was, and I have a bachelor's degree, so it just takes a little bit of effort. Now, let's say I do the same problem, but I'm going to show you something. So, contrary to the previous problems, I like to look to make the problem simpler. Can I factor something from 8, 26, and 20 to make my life so much easier? Yeah, they're all divisible by 2. That 2 is the GCF that I can take out. 2 times what is 8x squared? 4x squared. 2 times what is 26x? Positive 13x. 2 times what is 20? Positive 10. So now that the 2 is factored out, I'm going to incorporate that at the end of my answer. But now I can make my A 4, my B 13, and my C 10. So now I've made this problem easier for me to solve if I can factor out in advance. So now that my new A is 4, my new B is 13, and my new C is 10, what is my AC? Positive 40. What is my B? Positive 13. Once again, we've got a positive-positive combination. So even I know this off the top of my head. I could do this in 3 seconds, but I'm just showing you the table just to be thorough. 1 and 40. 1 times 40 is 40. 1 plus 40 is 41. Okay. 2 and 20. 2 times 20 is 40. 2 plus 20 is 22. But look at how much easier this is now that all we need to do is figure out what adds to 13. 3 would go into 40 as a decimal, so forget about it. So let's try 4 and 10. 4 times 10 is 40. 4 plus 10 is 14, not 13. Let's try 5. 5 times 8. 5 times 8 is 40. 5 plus 8 is 13. There we go. We have a winner. So 5 and 8 are the winning team. So now I can break this down. I can split the middle term and make this 4x squared plus 5x plus 8x plus 10. So now I'm going to split the middle term and put them in the respective spots of the rectangle that I create. So we've got 4x squared and positive 10 in their respective positions. Okay? And it doesn't matter which one I put, 5x or 8x. So I'm going to put positive 5x here and positive 8x here. I'm going to cover up this column. What can I do if I want to find the GCF of 4x squared and positive 5x? What number can I divide from both 4x squared and 5x and still get whole numbers? Well, the GCF of 4 and 5 is 1, so that's not really helpful. But luckily, the GCF of x squared and x is x. So 1x, technically. All right? X times what is 4x squared? 4x. X times what is positive 5x? Positive 5. 4x times what is positive 8x? Positive 2. And check my work, 5 times 2 is 10. Yep. So remember, I factored out a 2 in advance, so I'm going to put that at the bottom. 2 times the quantity of 4x plus 5 times the quantity of x plus 2. And that's exactly what I want. Notice that in problem number 1 and problem number 2, I got the same result, but one took a little bit more effort. So that was the result I got in problem number 1. And this is the result I got in problem number 2, pretty much the exact same factored out form. Okay, so let's do problem number 3. Let me just make sure. Problem number 3. Yeah, there's 6 problems today. Problem number 3. See if we can do this one. Okay, so we've got 8x squared minus 24x plus 18. What can I factor from 8, 24, and 18 and still get whole numbers? Well, they're all even, so most definitely a 2. 2 times what is 8x squared? That'd be 4x squared. 2 times what is negative 24x? That'd be negative 12x. And 2 times what is positive 18? Positive 9. So now I can't factor anymore. No, 4, 12, no, I can't factor by 2. I can't divide by 2. Can't divide by 3 either. Okay, so it's as factored as it's going to get. So now I got to get creative and make this A equals 4. Oh, my hand slipped. A equals positive 4. B equals negative 12. And C equals positive 9. So now I need to figure out what multiplies to AC and adds to B. So my A is 4, my B is my A is 4, my C is 9. So my AC is 4 times 9, or positive 36. But my B is negative 12. So if I look at this, it could either be positive times positive or negative times negative. But since it adds to a negative, it has to be the negative-negative combination. So let's get to work. Negative 1, negative 36. They multiply to 36, but they add to negative 37. Let's try negative 2. Negative 2 times negative 18 is positive 36, but they add to negative 20. Negative 3. Negative 3 times negative 12 is positive 36. Negative 3 plus negative 12 is negative 15. Negative 4 goes into negative 4 times negative 9 is positive 36, but negative 4 plus negative 9 is negative 13. Close. Let's try negative 6 now. Negative 6 times negative 6 is positive 36, but they add together to get negative 12. There we go. Now we're in business. Now we've got the winning team. Okay. So now that we've got, I'm going to pull down this factored form of 4x squared minus 12x plus 9. So now that I've got the winning team, the thing that's significant is that they factor into negative 6x and negative 6x. So I expand this polynomial into 4x squared minus 6x plus 9. Okay. So now I'm going to put them in their respective spots of the rectangle. 4x squared goes in the top left. Positive 9 goes in the bottom right. Hey, they're exactly the same. Yeah, pick which one goes which. Yeah. Negative 6x and negative 6x. Okay, so now I'm going to cover up one of the columns. What is the GCF of 4x squared and negative 6x? And I'm going to use positive whole numbers. Well, the biggest number I can divide out of 4 and 6 is 2. And of course, x squared and x share an x. So the GCF of 4x squared and negative 6x is 2x. 2x times what is 4x squared? That'd be 2x. 2x times what is negative 6x? That'd be negative 3. 2x times what is negative 6x? That'd also be negative 3. So hey, what do you know? You've got 2x minus 3 times 2x minus 3. And what did we factor out? We factored out a 2 in advance, so don't forget about that. So that's totally okay with me. I would be totally fine if you guys factored it out like this, or if you want to be fancy. Remember that these two are exactly the same. So the 2's factored out. So now I've got 2x minus 3 quantity squared. Pick one of these two and I'm happy. Okay, so I'll come back to this piece of paper. So for now, 6x squared minus 33x plus 15. See if you can do this problem independently by pausing the screen. Okay, so first things first, can I factor something from 6x squared, negative 33x, and positive 15? Yeah, the GCF of 6, 33, and 15 is 3. So I factor out a 3. 3 times what is 6x squared? 2x squared. 3 times what is negative, 3 times what is negative 33x? That'd be negative 11x. 3 times what is positive 15? That'd be positive 5. So if I factor out the 3, I've made my life significantly easier. So instead of figuring out what multiplies to AC on the top, in other words, that'd be 6 times 15 would be 90. What two numbers multiply to 90 and add to negative 33? I think that it would be much easier to figure out what two numbers multiply to A being 2 and C being 5. And B being negative 11 is what we want to add to. So remember that my AC is positive 10, and my B is negative 11. So I'm going to try to figure out, hey, what's the combination? Positive, positive, or negative, negative? It's negative, negative, because they have to add to a negative. So let's start with the obvious one. Negative 1, negative 10. Negative 1 times negative 10 is positive 10. But negative 1 plus negative 10, who would have thought we got it on the first try? So that's the winner. So what's the beauty of the right combination that gets us the winning team? Well, that means I get to split this middle term into negative 1x and negative 10x. So now I've got 2x squared minus 1x minus 10x plus 5. So now I'm going to put all four of these expanded terms into their appropriate positions of the rectangle. So 2x squared, positive 5, top left and bottom right. And now it doesn't really matter which one I pick. So I'm going to go with negative 1x and negative 10x. Cover up the right column. What can I factor out of 2x squared and negative 1x? Well, it's not very exciting. The greatest common factor of 1 and 2 is 1. So it's just 1, and x squared and x both share an x. So I'm going to factor that part out. X times what is 2x squared? X times what is negative 1x? Negative 1. 2x times what is negative 10x? negative 5. So then I get 2x minus 1 times x minus 5. But remember, I factored out 3 in advance, so I'm going to put that first. So the 3 gets factored out, and then I get 2x minus 1, and then x minus 5. And that is the completely factored version of the above polynomial, 6x squared minus 33x plus 15. Okay, so now we're going to do 2 more problems. All right, so let's take a look at problem number 5. 6x squared plus 3x minus 63. See if you can do this problem independently by pausing the screen. If you want to try the other one, you can pause the screen and do this one as well. Okay, so let's do problem number 5. Well, first things first, can I factor something from all 3 of these terms? Yes, I'm going to factor out a 3. 3 times what is 6x squared? 3 times 2x squared is 6x squared. 3 times what is positive 3x? You could put positive x. I like to put a 1 because I know I'm going to have to do more work. 3 times what is negative 63? Negative 21. And now I can't really factor any more, so now I got to get creative and do my ABC method. So the A is 2, my B is 1, and my C is negative 21. Okay, so now I'm going to make that table. 2 numbers that multiply to AC and add to B. So A times C, 2 times negative 21 is negative 42. And B is positive 1. So I cover up the side and I say to myself, okay, in other words, we need to get to negative 42. So one of them has to be positive, one of them has to be negative. Now the question is, what does that add to positive 1 tell me? The positive needs to be a little bit stronger than the negative. So let's make a table. Negative 1, positive 42. Negative 1 times 42 is negative 42, but negative 1 plus 42 is 41. Nope. Let's try negative 2. Negative 2 times positive 21 is negative 42, but negative 2 plus 21 is 19. That didn't work. Let's try negative 3. Negative 3 goes into 42 14 times. Sorry, negative 3 times 14 is negative 42, but you add them together and you get positive 11. Okay. 4 does not go in there unless it's a decimal. 5 also does not go into 42 unless it's a decimal. But 6 does. So let me try negative 6, positive 7. Negative 6 times 7 is negative 42, but negative 6 plus 7 is positive 1. We have a winner. So now we've got negative 6 and positive 7 as our winning team. And the beauty of having this as our winning team is now I can split this up. We've got 2x squared plus 1x minus 21. I'm going to spread this out and split it between negative 6x and positive 7x. So now I've got 2x squared minus 6x plus 7x minus 21. So now I'm going to make that rectangle, and let's factor out some GCF. So I've got 2x squared in the top left. I've got negative 21 on the bottom right. And I'm going to put negative 6x here and positive 7x up on the top right. It doesn't really matter which one's which. So now I'm going to factor out the GCF of 2x squared and negative 6x. That'd be 2x. 2x times what is 2x squared? X. 2x times what is negative 6x? Negative 3. X times what is positive 7? So then I'm going to check my work. Negative 3 times positive 7 is in fact negative 21. So now I'm going to go to my final answer. Remember what I factored out ahead of time? I factored out a 3. So I factored out the 3, and I'm left with x minus 3 times 2x plus 7. Okay. All right, last problem of the day, and then we'll call it a day. 8x squared minus 38x minus 10. What can I factor from all three of these terms? Well, I can factor out a 2 from all three of these terms. So 2 times what is 8x squared? 2 times what is negative 38x? And finally, 2 times what is negative 10? Okay, so now I've got a new A, B, and C. My A is 4, my B is negative 19, and my C is negative 5. So now I've got to make my new table where we multiply to AC and add to B. So two numbers that multiply to 4 times negative 5, which is negative 20, and add to negative 19. So I'm going to cover this up just to clear my head. If it multiplies to get negative, then that means that one of them has to be positive, one of them has to be negative. What does the add to negative 19 tell me? The negative has to be stronger than the positive. So what this means is I'm going to start with a weak positive and a strong negative. Let's try positive 1 and negative 20. Well, 1 times negative 20 is negative 20. 1 plus negative 20 is negative 19. Hey, we got this on the first try. So I'm going to stick with the factored inside, the 4x squared minus 19x minus 5. I'm going to split this up into positive 1x and negative 20x. And now I've got 4x squared plus 1x minus 20x minus 5. And now for the grand finale, the rectangle. Okay, so now I'm going to put all the pieces in. I've got 4x squared in the top left. I've got negative 5 on the bottom right. And I'm going to put whichever in the corners. Let's go with negative 20x here and positive 1x here. It doesn't really matter. What is the GCF of 4x squared and negative 20x? What can I factor out of both of them? Well, I can factor 1, 2, and 4. So the GCF of 4 and 20 is 4. And remember, I can factor out an x from the x squared and the x. 4x times what is 4x squared? X. 4x times what is negative 20x? Negative 5. X times what is positive 1x? Positive 1. So remember, what did I factor out ahead of time? I factored out a 2. So don't forget about that 2. So now 2 times 4x plus 1 times x minus 5 And that is the completely factored form of the original polynomial. Have a good day, and we'll see you guys in the next video.